Hi guys, well, I finally got the ugly duckling to work. As you can hear, well, it's not high fidelity. By the way, this is a French radio station, but unfortunately there aren't that many radio stations, well, AM radio stations where I live, so tuning in on one is a bit of a pain. Anyway, as you can hear, it works. So what I did to get the radio finally to function is this. On the schematic, as you can see here, there are all sorts of voltages written down or printed next to the pins of the tubes and other parts. And I started to measure each voltage or each pin for the voltage which is on it. And I did that systematically, going from one tube to the next. Now I did notice that voltages were quite off in certain cases. Well, okay, if I say quite, let's say by half a volt, maybe a volt, in one or two cases even 2 or 3 volts. And I just couldn't figure out what was going wrong. So I measured all those voltages one by one, and I even measured all the resistances which are marked here in this little table, one by one. I did fix an open connection, which was up here at the oscillator coil, but that still didn't get the radio to function. So in the end, after also having changed all the tubes for other tubes, I finally got so frustrated with it all that I started to check the circuitry, well, part by part. And it turns out in the end I had made one mistake, just one, because you'll remember I refurbished the IF coils, and as you can tell, the IF coils work. The IF coils work admirably. So the problem were not the IF coils, obviously. So what was the problem? Well, this capacitor. I don't know if you can see it, but right where my finger is, you can see this is a 2000 picofarad capacitor, or translated into nanofarads, 2 nanofarads. Now, in physical terms, the 2000 picofarad or the 2 nanofarad capacitor is, I'll take my pointer, is this one. Now, you remember that originally I had fitted to the radio my homemade capacitor network as a replacement for the original one. But I wasn't entirely certain that it would work. So I tacked loose capacitors instead of this capacitor network on the tube. Now, as I was saying, it turns out that this 2 nanofarad capacitor which you see here was not connected between the right pins. I had made a beginner's mistake, which was that if you look at the capacitor network, you can see there are numbers which depict the pins of the capacitor network. And what I had done was to connect this 2 nanofarad capacitor between pins 1 and 2 of the 1U5 tube. But of course that was wrong. I didn't have, I shouldn't have connected it to the pins 1 and 2 of the 1U5, but to the pins 5 and 6. So between the pins 5 and 6. It turns out that pin 5 of the 1U5 is not connected. It's simply not used. So they use it as a solder point. And the lead, this lead here, which comes from the volume potentiometer, is soldered to pin 5 of the 1U5. So I should have soldered the leads of the 2 nanofarad to the pin 5 of the 1U5, to which the lead of the volume knob or the volume potentiometer goes, and the pin 6 of the 1U5. And believe it or not, that did the trick. The radio immediately came to life. So as the lesson I got out of that is that when you repair a radio, you should never take your repairs at face value. You should always double check them. Okay, so, well, the radio finally works. So, what did I do up to now to the radio? Well, as you can see, if we start from the power supply part of the radio, I built in a fuse holder, which you see here. So that's the first thing I did. I also attached a new lead to the radio. Now, I did use a modern lead and not a vintage type one, because, well, I've been looking around for vintage leads, but the prices that they ask for new old stock or even fake manufactured vintage leads are ridiculously high. So I took a cheaper modern model, and if I happen to find a new old stock or a genuine AC lead somewhere in the future, well, and it's reasonably priced, I'll buy it and then I'll retrofit it to the radio. So, okay, I fitted a new AC cable to it, and then I made some changes, maybe some of you recall, to the rectifier part of the radio. Now, there is a detail which I hadn't shown before, which is that originally, instead of the solder lugs you see here, there was mounted a small selenium rectifier. But it turns out the selenium rectifier had completely burned through. So I mounted this solder lug holder and I soldered to it a brand new 1N 4007 rectifier. I think it's a 1N 4007. I'm not entirely sure, but I think that's what I used. and the detail I hadn't shown when I made this change to the radio was this high power resistor. This in fact is a 3-watt resistor. I think it's just a carbon type resistor, but of 3 watts and 100 ohms. Now, why did I do that? Well, if you notice on the schematic, if you see the diode on the schematic right here, a little bit above the diode is marked that there should be 100 volts right here where I hold my finger. Yeah. Now, when I noticed that when I switched on the AC power to the radio, by the way, I'll switch off my separation transformer so that I don't electrocute myself. Anyway, so what I noticed when I measured the output of this diode was that there was about 116 volts here instead of 100 volts. So obviously the tension or the voltage was way too high for the radio. So what I did actually was I put my voltage meter to a setting of amperage measurement, and I measured how much power the radio was drawing from the power supply. And it turns out it consumes at maximum volume about 93 milliamps, which isn't a lot of current, but still. So I calculated that if I had to drop, let's say 16 or 17 volts at a current of 93 milliamps, that would take around about a 100 ohms resistor, which is exactly what I did. So I tacked a 100 ohm 3-watt resistor here. It gets pretty toasty when the radio is functioning or working, but that's okay. I mean, it can dissipate the power and easily, and as you can see, it's not burnt or even discoloring, so it's perfect. So that's what I did for the power supply. Then you'll recall from one of the previous episodes, I also refurbished the only electrolytic capacitor in the radio. Actually, there were 3 electrolytic capacitors inside this cardboard tube. One 60 microfarad, I think. Let me have a look. Yeah, one 60 microfarad, one 40, and one of 250 microfarad. So I changed those 2. Then I proceeded to change a few wires which were, well, seriously burnt and ugly and dirty. What did I do then? Oh yeah, well then I started to change, or rather to replace all the capacitors and resistors that were off value in the radio, or on the chassis, I should say. So that's what I did. I left in maybe 2 or 3 original resistors, like over there, I don't know if you can see that, but right here under this lead, there's one of the original carbon type resistors. So I didn't change all the resistors, but only those that were either off in value uh, or that were really very dirty or which looked burnt. Not only did I have to replace a lot of parts, but it turns out I also had to make a small alteration to the circuitry. If you look carefully at the schematic, you'll notice here, right here, is marked a 3.3 mega ohms resistor. And I put a question mark next to it. And the reason is that no matter how hard I looked all over the chassis, I just couldn't locate this 3.3 mega ohms resistor. It was simply nowhere to be found. And as you can see, it connects the IF can you see here, the secondary IF stage, all the way up like this and this and this and this and this and this and this, and it goes right up to the oscillator variable capacitor part. Yeah, the tuning gang, one of the tuning gangs of the variable capacitor, this one in other words. And well, that resistor which seems to connect the local oscillator part with the secondary IF coil, or I should say the detection IF coil, well, it was simply gone. Now, that makes me suspect that somebody in the past must have cut this resistor away. And I'm not entirely certain, of course, I'm not an expert, but I think this resistor and well, in fact, the whole circuit with this resistor is intended to be used as a carrier detection or carrier strength detection, to be used for the automatic volume control, or the AVC part, which is built around the 1U5. So I don't know for what reason somebody in the past had simply removed this resistor, and it's this one here. You see it floating, floating above the circuitry. So I still have to tuck it away nicely within the whole circuitry of the radio. Alright, so in a few words, that's what I did to the radio. Now, before I can finish the project entirely, I need to do basically one more thing before I can start work on the aesthetics of the radio. And that is that I need to build back in the capacitor network I had built, the replacement capacitor network, and see whether the radio still functions correctly with my home-built capacitor network. If it does, then, well, the electronic part of the restoration will be more or less over and done with, and then I'll probably make perhaps one more episode about the restoration of the aesthetics of the radio. Now, mind you, this radio was pretty beaten up, and if you recall the very first episode of the Westinghouse restoration, the cabinet of the radio was painted red. So one of the previous owners of the radio had apparently an urge to paint it completely red. So, well, I still have to take care of that mess. And also, the buttons which are mounted on this radio are really, well, beaten up. If I show you, this is the tuning knob, and as you can see, well, it's full of paint, and of course there's white paint on it. I'm sure Bob will smile if I say this, but yes, even on a red painted radio there are white paint spots. I don't know why, but well, it seems to be typical of vintage radios that one way or another there is white paint landing on them. Anyway, so restoring the aesthetics of the radio, that will take a little bit of doing. Probably, you know, I'll even end up looking for a replacement knob. Whether it'll be a real one or a reproduction, I don't know. But, well, this knob is really too ugly, actually, and it's going to be a pain to try to restore it to its original looks. So I think in the end I'll just look for another knob. Also, if you take a look at the inside, whomever had this radio at one stage or another had broken the tuning knob. As you can see here, as the side of this knob has split, has broken, and the repairer, whoever that was, decided to use copious amounts of any kind of glue and glue back that part and hold it together with a spring, a steel spring you see here. So anyway, it's an ugly knob, but for the moment it will do. I guess it wasn't the end of the video. I just wanted to show you that the radio works actually with the capacitor network I built to replace it, or to replace the old capacitor network. Well, and as you can hear, it works. So yeah, I couldn't resist making these last few seconds to show you. Alright, so that's now, it's truly the end of the video. Whoop. So stay tuned, guys, for another update.
Because it led to you breaking a lot of promises, and it wasn't just tuition fees, which many people focused on. Of course, the central economic plan that you signed up to, the deficit reduction plan, which you signed up to, was very different from that you campaigned on. The problem that it does have is that Nick said he changed his mind on a degree of deficit reduction needed. And he said that he'd made up his mind to do that several weeks. Nick's documentary stated several weeks in 1962 in Scotland. And had they known that, thousands of those people would have made a different decision. And that is the problem.
Seen the particular example of Swindon, where the Conservatives already made a gain from Labour, and if that proves to be typical, then indeed one of the councils that were confidently expected on the basis of the relatively modest Labour lead in opinion polls that the Tories would lose, apparently that target may well be missed.
Just explain the significance of 2012 as opposed to 2010.
Well, remember that the last time these councils had elections was 2 years ago. To be able to demonstrate that indeed a year away from a general election, that indeed it is indeed still commanding the votes of the public as successfully as it were absolutely in the midterm of the Parliament. And the truth is it's already very clear that the Labour Party is not winning votes in these elections on anything like the scale that it did in 2012, and therefore does raise questions. And those questions have been there, frankly, throughout this Parliament, about the degree to which those people who say they're going to vote Labour are necessarily submission and committed to the party, that they're going to see it all the way through to 2015. It looks as though on the basis of tonight, a significant proportion of people who were willing to vote for Labour 2 years ago withdrew that support yesterday.
And you know where it's gone?
No, the truth is, so far, it is too early to say who is suffering most from this UKIP rise. I mean, it's certainly true everybody is suffering. Whether or not the Conservatives are suffering more than the Labour Party is yet too early to tell. I mean, certainly I think in some of the earlier conversation there was rather too much of a simplistic assumption, perhaps from Jacob Reed-Smart, that all people who voted UKIP have come from the Tories. That certainly is not the case. According to opinion polls, only around 30 to 40% of current UKIP supporters are ex-Conservatives. It's true that Conservatives are more likely to go to UKIP than Labour voters, but according to the opinion polls, there's a non-trivial proportion of Labour voters, people who voted Labour in 2010, who are now backing UKIP.
Okay. Swindon's been held by the Conservatives, but Chuka, would you like to... did you accept what John Curtis is saying?
Let me just say a few things about that. First of all...
You can talk to him.
Sorry, John. First of all, you'd accept that we have not got that many results yet. We have many, many more to come in, so before we can actually...
we would, Chuka, but we've just got a result in from Birmingham. Again,
but
over 25%.
But John, you accept actually we've still got a lot of votes to go. That's the first thing. The second thing I would say, would I deny that UKIP is having an impact on us? Of course I'm not going to deny that UKIP is having an impact on us. It's having an impact on everybody. I think the other thing, John, that I'd be interested to get your kind of take on is, obviously, I mean, if you look at London, for example, we had different turnout in the last time, 2010, which had an impact on the vote. And the other question I had for you is, what's your reading of the impact of having the Europe.
After a tip I got from Bob, who has the B. Anderson YouTube channel, B. Anderson TV channel, I mean, I decided to follow up on his tip and not build the capacitors inside of the IF can as I originally planned. So, well, one reason of course is that the IF can is really very small, and if I have to fit in capacitors together with this coil assembly you see here, well, it's going to be a tight squeeze. So I don't think it's really a good idea to build the capacitors inside the IF can indeed. Therefore, what I need to do now is to insulate these contacts from each other. You see them on top of the base here. And of course they shouldn't make any sort of short circuit between them, because, well, obviously that would probably ruin the whole radio. So what I'm going to do now is I'm going to cut tiny pieces of shrink tubing like this, and I'm going to fit them over one of the contacts on each side, and then bend those contacts which are pointing straight up back flat and flush with the base. And then I will probably need to attach them with a little bit of glue, because as you can see they can move freely inside the base, and that's not good. So I will probably end up mixing a little bit of epoxy glue and glue them into the base of the IF cam. I don't know whether I will put back the top of the base, which I'm keeping in a little plastic bag here. So I don't know if I'm going to put back the top and the clip which held the top plate back onto it. Maybe I will, just to give it a slightly more authentic look. I'm not sure yet. Anyway, after I've done this, I need to resolder I have to place back the IF coils on top of the base, and then I have to resolder the little wires which connect the IF coils to the leads at the base of the IF cam. Now the copper of these tiny wires is lacquered, so I will probably have to clear the lacquer off the ends of the wires, and most probably I'll do that by using a little bit of acetone. Acetone will probably take off most of the lacquer, and then I'm going to use tiny pieces of wire wrapping wire, which you can see here. I bought a whole roll of it, and wire wrapping wire, as you can see, is quite thin. I'm not sure, but I think it's 28 gauge wire, so it's really thin. Let me see. No, it doesn't say, but as you can see here, this is wire wrapping wire. So I'm going to build a small extension of wire wrapping wire to those little copper ends here. I'm going to solder some wire wrapping wire to them, and then I'm going to solder the wire wrapping wire to the base contact. Basically, I'm going to do that because those copper wires are really very short and fiddly to work with, and I don't want to cause any more damage than there is already done by cutting them. So that's it. I'll return with another update when I'm done.